Welcome back to Bee Spice. In this session, we'll continue with mastering alarms. In session 8, we'll talk about the very important aspect of alarms, cost of poor alarm performance. So if we don't, manage alarm well and if we neglect alarm, then what would be the damage, what would be the impact. So in this session we are going to talk about the some of the accident happens due to poor alarm management. So one is such Texaco refinery mill, Milford Haven, UK in 1994. This incident occurred. Then Longford gas explosion, Australia, and it occurred in 1998. Then BP, British Petroleum, Texas City Refinery, Texas City in 2005. Then Brownsfield Oil Storage Depot, UK 2005 again. And Enbridge Incorporated Pipeline Structure, Marshall, Michigan 2010. And Columbia Gas Pipeline Rupture, West Virginia 2012. And Prior Trust well blowout, Pittsburgh, Oklahoma 2018. Then BP Husky Toledo Refinery, Oregon, Ohio 2022. So these are the 8 incidents we are going to talk. This is more of a awareness video. And of course, yeah, it is very important to know the importance of alarm. So we have been covering the alarm performance, all these. But, we should also know this incident, right? Okay, first we'll talk about the Milford Haven Refinery, UK 1994. Okay, friends, this explosion, it happens in UK, right? 1994. This resulted in a plant damage. Just imagine, which cost 48 million euro to repair and loss of production, which significantly affected the UK refining capacity. And there were 26 minor injuries, and that's, yeah, unfortunately there is no serious injuries or fatalities. Okay, so the plant owners were fined 200k euro plus additional cost. The accident was happened by equipment failure coupled with a poor design of modification. With a hindsight, we can say the plant operators had ample time to recognize and prevent the accident. But they were hampered by the lack of good view of the graphics, right? So the graphic overview was not there on their video display, and also the facts, the alarms are being presented at an estimated rate of every 2 to 3 seconds in the 5 hours. Every 2 to 3 seconds, it's keep on coming. So people, lose control. So totally there was 275 alarms in 10 minutes before the explosion. Just imagine. So now you know the importance of the managing alarm. That's why we are bringing this lesson actually. Okay. Of course, we are in session 8. There are many more. Okay. So this is the first incident. Then second incident, Longford gas explosion. Okay, so this happened on 25th September 1998. Okay, at 12:25 p.m. Okay, an explosion and fire occurred at the Longford, Australia gas production facility of ESSO. Okay, as a consequence, 2 people were killed, 8 people are injured, and all natural gas supply from Longford facility to the users in Melbourne and much of Victoria ceased for 2 weeks. Okay. So, when they investigate, the Longford Royal Commission report noted that contributing factor in the explosion was an inappropriate response to a critical process alarm. So that is the point. So the lessons from Longford by, Andrew Hopkins observed that self-regulation and commercial pressures allowed a system to develop where staff, used to operate the plant outside specified limits with warning alarms constantly ringing. It allowed the environment to operate where an average of 300 alarms went off each day, with one incident causing 8,500 alarms to trip, or 12 every minute over a 12-hour shift. So this environment, totally desensitized the operators to alarm. You just imagine 300 alarms went off each day, okay? And with one incident causing 8,500 alarms. So that is why, the rationalization, all these should be in place. So this is the second incident, okay? Then we talk about the third incident. This is BP Texas City Refinery, okay? So this happened, on 25th March 2005, an explosion at the BP refinery in Texas City. It killed 15 workers, injured 118 others. It causes a major alarm in the community, led to the financial loss of 1.5 billion US and a significant impact on the reputation of the British Petroleum. So the subsequent investigation revealed that one of the contributory cause of the accident was failed management of instrumentation and alarms. So that's the beauty of this. We need to really top of the alarm management. We should not neglect it. Okay. Then we have the Bunsfield oil storage depot, Hertfordshire, UK, 2005. Okay. In the early hours of Sunday, 11th December 2005, a number of explosions occurred at Bunsfield oil storage depot. Okay. UK. At least one of the initial explosion was of massive proportion, and there was a large fire which engulfed a high proportion of the site. Over 40 people were injured. Unfortunately, there were no fatalities. Significant damage occurred both to the commercial and residential properties in the vicinity, and a large area around the site was, evacuated on emergency service advice. The fire burned for several days, destroying most of the site and emitting large clouds of black smoke into the atmosphere. The subsequent investigation identified that the central factors were the shortcomings in the design, provision, and operation of the protection alarm and the shutdown system. So this investigation resulted in the criminal prosecution and finding of five companies, including the owners, operator, maintainer, and of course the equipment supplier. Friends, I had a very good experience in this. Because of this incident, in our refinery, when I was a team leader, I was working one of the project actually for the tank overfill automation system, only because of this incident. Okay, so that's the Bunsfield oil storage depot. Then we have a Enbridge Incorporated pipeline structure, a pipeline rupture, Marshall, Michigan, 2010. See, on Sunday, July 25th of 2010, a segment of 30-inch diameter pipeline, okay, owned and operated by Enbridge Incorporated, ruptured in a wetland in Marshall, Michigan. The rupture occurred during the last stages of the plant shutdown and was not discovered or addressed for the over 17 hours. A total release estimated to be of 3,200 meter cube, of what do you call crude oil was released. So this yeah, sorry, I think two, three, sorry, that 3,200. Okay, I'll tell you in gallon. 843 444 gallons. Okay, 843 444 gallons of crude oil was released. Okay, so that oil saturated the surrounding wetland and flowed into the Talmadge Creek and the Kalamazoo River. Actually, that's damage to the environment. So about 300 people reported symptom consists with crude oil exposure. No fatalities were reported. That's it. So the pipeline rupture was caused by corrosion. Okay. So the investigation, found that the pipeline leak detection and SCADA system generated alarms consistent with the ruptured pipeline throughout the incident. That is, 17 hours during which oil was being released. However, the central control staff failed to recognize that the pipeline had ruptured until notified by an outside caller. So that is the problem. So they attributed the alarms to the shutdown and interpreted them as indications of an incompletely filled pipeline, so which occurred frequently during normal operation. So it's a wrong interpretation. So they continued to pump oil despite receiving more leak detection alarms and noted large difference between the amount of oil being pumped into the pipeline and the amount being delivered. Inadequate training and procedures for leak detection were identified. So ultimately, all boiled down to the alarm. So you can understand the beauty of managing the alarm. So that is about the Enbridge Incorporated pipeline structure. Then we go into the Columbia pipeline rupture, Virginia. Yes, West Virginia 2012. Okay. So on December 11, 2012, a buried 20-inch large diameter pipe, interstate natural gas transmission pipeline. It was owned and operated by Columbia Gas Transmission Corporation, ruptured in a sparsely populated area of, Sissonville, West Virginia. So a section of the pipe was separated and ejected from the underground pipe, okay, landing more than 12 meters from its original location. Okay, a section of the pipe was separated. So the escaping high pressure natural gas ignited immediately. Three houses were destroyed by the fire and several of the houses were damaged. There were no fatalities or serious injuries. About 2 million standard cubic meters, that is, yeah, of natural gas was released and burned. Okay, so the pipeline failure occurred due to the corrosion. Okay, the point is here. The investigation found that the SCADA system had been configured with alarms and alerts. Pipeline pressure deviation, which may indicate pipeline rupture, was notified to the operator as an alert. The alert screen displayed the parameter and its indicated value, but it did not indicate whether a new value was an increase or decrease or display the amount of change. That's a problem. The way we configure is also matters. So to understand the significance of alert, controller had to know the value of the previous parameter either from the prior displayed alert value or from observing the parameter on a system display screen. So recognizing the significance of alert, was further complicated by the fact that the controller was reviewing and responding to other SCADA parameters on the two pipeline system. He was overseeing during the 1 to 2 minute span between the pressure deviation alert. So this also, contributed actually. So this is about the Columbia gas pipeline rupture, West Virginia 2012. Then we have a Pyro Trust Well Blood, Pittsburgh, Oklahoma, 2018. So, on Jan 2022, 2018, sorry, on Jan 22, 2018, a blowout and a rig fire occurred at Pyro Trust, okay, gas well number, okay, that number leave it. So, located in Pittsburgh Country, Oklahoma, okay. Five workers were killed due to thermal burn injuries, smoke, and soot inhalation. So the blowout occurred while removing the drill pipe out of the well. Okay. So the blowout occurred while removing the drill pipe, tripping out of the well. So it was caused by the failure of both the primary barrier and the secondary barrier. Okay. So primary barrier in the sense the hydrostatic pressure produced by the drilling mud, and the secondary barrier means the human detection of influx and activation of the blowout preventer. Anyway, forgetting. So the investigation found that the alarm system had been deactivated. You just see. Both the day and night driller elected to turn off the alarm system, which likely contributed to the crew missing key indication of the well control event. So the alarm system was not effectively designed to alert personnel to hazardous condition during different operating states, meaning drilling, tripping, circulating, surface operation, and would have surrounded, excessive non-critical alarms during the 14 hours leading to the blowout, which likely led to the drillers choosing to turn off the alarm system. See, too much of alarm also, is a major concern. So that's about the pyro trust well blowout. Okay. Then the last but not the least, the BP, British Petroleum, Husky, Toledo Refinery, Oregon, Ohio 2022. On September 2022, a naphtha release and a fire at the BP Husky Toledo refinery fatally injured two employees. They were brothers. A vessel that normally contained vapor, like fuel gas for furnace or boiler, right, had become filled with liquid naphtha when an upstream tower overflowed. Okay. So the other refinery unit had been shut due to the loss of containment incident that occurred early that morning. Okay. The employees who were killed started to drain the vessel, releasing the liquid naphtha to the ground. So the initial process upset that occurred 2 days before the incident, The subsequent events and operational decision led to liquid naphtha filling the vessel. Okay, so alarm flight was identified as one of the contributing factor. Okay, in 12 hours, a total of 3,712 alarms are recorded. Okay, so the workload created by the alarm flood state contributed to delays and errors in responding to the critical alarms and in shift to shift communication. So ultimately, again, the incident is boiled down to alarm. Too much alarm is too dangerous. Okay. And of course, it has to be categorized, it has to be rationalized, it has to be prioritized. Okay. So that's all I have for this session, friends. By now, I hope you know, got some insights on the real insights on the, importance of maintaining the alarm, you know, what do you call rationalization and avoiding unnecessary alarms, all these, right? So far, we have been covering that in that way only. Of course, this is only eighth session. Many more to come. Stay tuned. Take care. Bye bye.